I'd like to thank the organizers for giving me the opportunity to talk today. And what I'd like to address in the next 8 minutes is a challenge to the orthodoxy concerning lek mating systems and the prevailing view that males in lek mating systems contribute only their genes to the next generation. Now, what I'd like to propose as an alternative is what I'll refer to as the sentinel decoy hypothesis that was published years and years and years and years ago. And what this hypothesis suggests is that displaying males can benefit females directly by reducing nest predation. And they can do this either by serving as sentinels that can alert females when a potential predator is nearby, or by serving as decoys, where the male displays will attract predators and lure them away from female nesting sites. This is shown sort of crudely here in this simple example, where over the course of the breeding season, these dots, which are predators, are assumed to move randomly in the habitat until they move within range of the male displays, which are shown here by the circle with the male display site at the center. And once they are able to detect the male displays, the assumption is that this will bias their movements so that after several iterations, there will be an accumulation of predators in the vicinity of the male display site. But more importantly, this will clear out a zone just inside the range of male displays, where the density of predators will effectively be lower, and therefore there will be a lower likelihood of predation on females' nests. Now, the first question, of course, is, are nests located within the range of male displays? And in the case of the prairie grouse, the mean distance of nests from the nearest lek ranges from about 2/3 of a kilometer in lesser prairie chickens, about 1 kilometer in sharp-tailed grouse and greater prairie chickens, up to about 2 kilometers in sage grouse. But remarkably, the distance at which human observers can hear displaying males is more than twice that distance. And the distance at which aerial predators can visually detect displaying males is also likely to be quite a bit greater. So nests in this case are clearly located within the range of male displays. Furthermore, male displays occur at times of day when nesting females in these prairie grouse are most vulnerable to predation. And this is because, males display early and late in the day. And these 2 times of day are when females leave the nest and leave the nest in order to forage, and are vulnerable both because they're moving around and because the uncovered eggs are highly conspicuous. Now, where are nests located, and how is the distribution of nesting success located relative to male display sites? So these are data, again, for 3 prairie grouse, lesser prairie chickens, sharp-tailed grouse, and greater prairie chickens, where the upper plot is the distances of successful nests from the nearest display site, and the second is the distances of unsuccessful nests that were preyed upon. I don't have time to go through this in detail, but what I've done here is to pull the data from all 3 species by normalizing the data with respect to the average distance of nests from the nearest display site. And what you can see here is that in the central third of this range, the nesting success is roughly 3 times higher than it is for nests that are either closer or further away. So here, 1 is the mean distance of nests from the nearest lek in each species, 2 is twice that. And here then, there's roughly a tripling of nesting success in a fixed distance from male display sites. Now, is this dependent on the presence of displaying males? And in the 2 studies of prairie grouse, data was available on the timing of nests. And what it turns out, remarkably, across 2 studies done years apart, 2 different states, 2 different investigators, is that early nests, when males are displaying, were very tightly clustered. And 6 out of 11 were escaped predation. But nests that were incubated after male display had largely tailed off were varied much more in their distance from the nearest lek and only 1 out of 10 had any surviving offspring. In fact, it was partially depredated. Now, why might male display in these prairie grouse be effective at biasing the behavior of potential predators? And a large number of authors have described the advertisement displays in most flecking birds as involving slow labored flight, rapid fluttering flight, or frenzied, often asymmetrical wing flapping. And several then have noticed or ever remarked on the resemblance to the distraction displays used by females in lekking and non-lekking species to lure predators away from their eggs and young. And so the possibility is then that at least some features of male display may contribute or may enhance the effectiveness of displaying males as sentinel decoys. Now, the potential problem with the sentinel decoy hypothesis, sorry, I'm losing my voice, is that the predators that are attracted to male display sites are generally thought to not be the same as those that are primarily responsible for predation on nests and nesting females. But in fact, there are counterexamples. In this one, Hartzler reported that a bobcat killed a male sage grouse on a lek on 3 of 4 consecutive mornings. And so obviously that predator was present at the display site and not out where female nests were located. And basically the idea is that it's remarkable even that these observations were made. In fact, many mammalian predators could come and go from a lek before the first light. And when they detected the presence of a human observer, the odor of an observer, noise in a blind or whatever, could leave and never be detected. So obviously remote tracking techniques are needed to obtain meaningful data on the response of mammalian predators to displaying males. Now quickly turning to bowerbirds, Gilliard, who was Mr. Bowerbird of that era, comments that the display grounds of bowerbirds without question attracted predators. Remarkably, male bowerbirds mimic vocalizations of a wide variety of nest predators, kookaburras, ferrets, fisherbirds, whistling kites, humans, honey eaters, and so forth. But even more remarkably, male bowerbirds produce the mimicry of these nest predators more than 30 times more frequently in response to a disturbance in the vicinity of the male's display site. Females' nests are located often in dense foliage, but within the range of male displays in most cases. Females use different routes to approach and depart from the nest and often return in stages. But females will often freeze for minutes at a time if a predator is near the nest. So it'd be interesting to find out whether female bowerbirds respond to male bowerbirds mimicking nest predator vocalization and under what conditions they do so. So I'll have to stop there. Thank you.